Okay, so last week we talked about sequences in general. Now we're going to start getting to specific type of sequences. Okay? If you recall last week, I told you a sequence is just a function. All right? It's a function, and functions can be turned into graphs. They can be turned into sequences. They can be turned into points. They can be turned into input-output tables. They can be turned into a lot of different things. And what we're going to start doing is we're going to start turning them into equations, okay, or rules. So let's get it. Let's get to it here. Okay. So we have two types of sequences. One is arithmetic and another is geometric, okay? How do I tell the difference? Well, there's a couple ways to tell the difference. All right, but I'm going to talk about this graphically. So arithmetic, when you look at a graph of an arithmetic sequence, it's a straight line or linear. Okay, so it's a linear graph. When you look at a graph for a geometric sequence, we call this, it's going to be a curved graph. But more specifically, or we use a math term, we call it an exponential graph. Okay, so to be very specific about this, an exponential graph looks like this. Okay, or it could do this. It could go down as well. Okay, so when you see these exponential graphs, that tells you when you have a graph that curves based off these input-output tables or these graphs here, it's geometric. If it's a straight line, it's arithmetic. Okay, so this is basically looking at the graph. When we look at the sequence, like the actual numbers, I'll show you how to tell the difference between those as well. Okay, so let's start answering this problem. We have a sequence here. Okay, what I like to do is I'm going to plot these points. This is 1, 4. This one is 2, 8. The next one is going to be 3, 12. And then the last one is going to be 4, 16. Okay, so from here we could actually do an input-output table if we wanted to. So I'm going to do that just so it could help me explain what's going on. So our input-output, so we're using X and Y. Okay, it's 1, 2, 3, and 4. 1, 2, 3, and 4. And our actual sequence is always the output. So our sequence is 4, 8, 12, 16. Okay, so this piece right here that I boxed, this is our actual sequence. Okay, so I'm going to write that as our sequence. So this sequence is 4, 8, 12, 16. And I told you last week that your sequence is basically the output of your points or your function. Okay, so 4, 8, 12, 16. So looking for problem 1A, is this sequence that is shown by these dots, is it arithmetic or geometric? So looking at the graph alone, you're simply asking yourself, do I have a straight line or do I have a curved line? So if you look at the graph and I had to attach these dots, they are a straight line. So based on what I see, for the answer for 1A is graphically, I have an arithmetic sequence. Okay? And that's based on the graph. All right? What if I didn't have a graph and all I had was this sequence here? How can I tell it's arithmetic? And it's very, very simple. When you have a sequence, to tell if it's arithmetic, we just got to look on how do I get to the next term. Okay? So let me erase this here so we have some room. So if you look at my sequence, which I've given you here, because I took it out of the dots here, the points, what am I doing to get to the next term? Okay, in this case, if you notice, you're simply adding 4 each time. Okay, so in an arithmetic sequence, when we look at the graph, it'll be a straight line, but when we look at the sequence, to tell that it's a sequence, you are going to look at, are you adding or subtracting something? Okay, so if you add or subtract something to get to the next term, that automatically is arithmetic. Adding and subtracting is arithmetic, okay? We call this number here, this adding 4, we call this, is one of the vocabulary words you're going to see in the video today, a common difference. Okay, so if you have a common difference, you have arithmetic. Very important that we know that. Okay, so this is called common difference. When you add or subtract to get to the next number. All right, so in this particular example, my common difference is called 4. It's plus 4. Okay, that's what we're doing to get to the next term. So not only do I know this is arithmetic because of the straight line, but I also know this is arithmetic, and the reason I would say that is because of a common difference. Okay, and that's the answer for number 1. It's an arithmetic sequence. All right, so what does exponential look like? We know an exponential graph has to have a curve, or a geometric sequence is exponential, which means it has to be curved in this way. Okay, but what does the sequence look like? The sequence is when you multiply or divide to get to the next number. And we're going to show you an example of that in a little bit. So instead of, in this case, we are adding to get to the next number, a geometric sequence will have something multiplying or dividing to get you the next number. Okay? And that's what makes it geometric. This is called a common, I think the video calls it a multiplier, common multiplier. Okay, another word for this is common ratio. It means the same thing. So it's the guy that you're multiplying to get to the next number. Okay, so geometrics, the best way to think about it, arithmetic, adds or subtracts to get to the next number. Add or subtract something. Geometric multiplies or divides to get to the next number. Okay? So, how do we write a recursive formula? And again, this is given to you in the notes, so I encourage you to watch this. I'm going to briefly do it here. It's fairly easy. I'm going to give you 2 versions, okay? So, we're going to do function notation. So I'm going to give you the function notation version. And then we also, if you remember, we have the subscript version. There's both versions. Okay? So let's do function notation. So recursive formulas are very simple. Okay? We're going to start with the function name. So if you look up here, they actually gave us the function name. We're going to call it B because that's what they're using up here. Okay? So we're going to start with, in function notation, it's B parentheses N. If your function was F, it'd be F parentheses N equals. So what we're essentially doing is we're going to write the equation. Okay? So the equation starts off like this. B parentheses, this is just how you start it, N minus 1. Okay, and I'll explain that, and the video explains what that means, but I'll explain it in a little bit. And then we are going to figure out what's our common difference. So basically, for arithmetic, what am I adding or subtracting to get to the next number? And that, in this case, is we are adding 4. Okay? This is your function notation here. This is the equation for it. Okay? We do have to add one more thing. And this one more thing only is because it's a recursive formula. Next week we're going to talk about a different type of formula, but for recursive, we got to write in what is our first term. So we want our function and we want our first term. So if you look, our first term is what number? It's 4. Okay, so this is the function notation for this sequence. Okay, you have to put what you're adding or subtracting by, because we do have arithmetic. If you were geometric, you would just put what you're multiplying by. Okay, so this is kind of the template for it. It's B parentheses N, because it's function notation, equals, you always put B and minus 1. And then tell me what's happening. Are you adding or subtracting something, or are you multiplying something? And then the last thing you do is you got to let everybody know what number was your first number in the sequence. And this is how you let everybody know. Okay? Again, I'm going really brief here. I'm doing my best to explain it, but the video does a very good job of explaining this stuff. Okay? So please watch that video for today. All right, subscript notation is very similar to this. We're going to go B, but instead of parentheses, we just put it in the bottom of our letter. B subscript N equals B, and then the subscript is N minus 1 at the bottom. Again, what are we adding and subtracting to this? We are adding, in this case, we're adding 4. All right, and we got to let everybody know what was our first guy in our sequence. So B sub 1, our first guy in the sequence was 4. Okay, so again, these mean the same thing, just one's in function notation, one's in subscript notation. Okay, and then part C. We kind of did this last week. Can you now tell me the next 4 terms? Okay, so we know we're adding 4 each time. So we're simply just going to continue to add 4. So our next 4 terms is 16 plus 4 more. That would be 20. 20 plus 4 more would be 24. And 24 plus 4 more would be 28. Okay, so those are our next 3 terms. Okay, that is number 1. I know it's a lot of information, but this is information that you are going to get in that video today. All right, let's jump into number 2. Okay, right off the bat, you should notice that in problem number 2, we have a curve. Okay, and just like I mentioned, it's an exponential curve. You look, it has this shape here, and I'll connect it with a line. Okay, so it has like that curve, which tells me we don't have arithmetic. We probably have geometric. Okay, so to make sure we have geometric, we got to check, does our sequence multiply or divide to get to the next term? So what I'm going to do is create my sequence. How do you create your sequence? Let's find our points. So this is 1, 16, 2, 8, 3, 4, 4, 2, okay, and then it looks like it's 5, 1. Okay. All right, so let's put this in sequence form. Okay, so I'm not going to put it in function form, we're just going to put it in sequence form. Remember, sequence form is basically I'm just getting the y values. Okay, and we're going from left to right. So we don't start with the smallest because that's not what happened. We want to start with the first dot here. Our first term is 16. So our sequence looks like this. 16. Our second term in the sequence is 8. Ooh, it's a horrible 8. Our third term in the sequence is 4. Our fourth term in the sequence is 2. And then our fifth term in the sequence is 1. Okay, there is my sequence. So we have to decide based on what I see, is it arithmetic or geometric, okay? I pretty much know it's not arithmetic because we have a curve. All right, I'm leaning towards geometric, but we got to make it official. And the way we make it official is by looking at our sequence and asking ourselves, what am I doing? Am I adding, subtracting, multiplying, dividing to get to the next term? Okay, so if we look at this, I notice that to get to the next term for each guy, I am dividing by 2. Okay, we're dividing by 2 to get to the next term, and that follows the rule for geometric. If you look back up here what I wrote, in order for it to be geometric, you're going to have a graph that curves, very similar to these. And to get to the next term, you're going to multiply or divide something. And we notice that we are actually just dividing by 2. Okay? The other thing I want to mention is dividing by 2 is the same as multiplying by 1/2. So either way would be the correct way to think about this. Okay? So dividing by 2 is the same as multiplying by 1/2. You might see it either way. Okay, so now that we know this is geometric, so we have a geometric sequence. Okay, and how do we know this? Because we have what we call a common multiplier. A common multiplier, or another word for this is common ratio of, and the best way to talk about this is using what are we multiplying by. So You could put we're dividing by 2, but the mathematical correct way is saying we are multiplying by 1/2, because that's a common multiplier. So multiplying by 1/2. Okay, so notice the difference. Arithmetic is a common difference. This guy adds or subtracts. Geometric is a common multiplier or common ratio. He divides or multiplies. And we always want to try to use the multiplication version. So even though we're dividing by 2, multiplying by 1/2 is the same thing. And that's the mathematical way of doing it. Okay? What is the recursive formula for this sequence? It's actually simple. It's the same thing. We're going to do function notation and subscript notation. So function notation is, we're going to use b again. B of n equals b n minus 1. Okay, and we are now, instead of up here we did adding 4 because we added 4. Now we are basically multiplying by 1/2. So times, in this case, 1/2. I like to do the multiplication version and not the division version. Always turn it into multiplication. It makes it simpler. Okay? But because we have recursive, this is the idea behind recursive, we got to put our starting number. So our starting number, which is b starting at 1. So we look, what was our 1? Our starting 1 was 16. So we put b1 equals 16. So that's the function notation. Okay, subscript notation, same idea, but we're using subscripts. So b subscript n equals b subscript n minus 1 times 1/2. And then since it's recursive, we got to let everybody know which one was our first number in our sequence. And our first number in this case was 16. Okay? So now we want to find the next 3 terms. So the last term we had was 1. So in your calculator, we're going to take 1 and divide it by 2. So 1 divided by 2, 1 divided by 2, looks like that, 1/2. Okay? If you want decimal form, you could also do 0.5. For me, it doesn't matter. So I'll give you both versions. So now to get to the next term, we've got 0.5 or 1/2. Just divide it by 2 again, or multiply it by 2, or by 1/2. Okay? So 1/2 divided by 2. Okay, we get 1/4 or 0.25 if you're doing the decimal version. Alright, now to get to the next guy, we take 1/4 divided by 2 again, or multiply it by 1/2, which is the way you want to do. And if you do 1/4 divided by 2, you get 1/8. Okay, and 1/8 is going to be 0.125 in decimal form. So those are your next 3 terms. Okay, so let me sum up this page. I know it's quite a bit of stuff going on. Okay, arithmetic is a straight line in a graph. It's going to have something adding or subtracting called a common difference. When you look at the sequence, we're adding or subtracting something. Geometric is going to be a curved graph. Okay, and it's going to have multiplying or dividing when you look at the sequence. We're always going to write function and subscript notation. Make sure we're comfortable with both. This is the template for it. It's always, in this case, we use the letter B. b parentheses n minus 1, and then you tell me what you're adding and subtracting, or if you have multiplying or dividing here. Okay? And after that, you tell me your first term by using this. And we do the same for subscript. Alright, let's go ahead and do number 3. So here's our sequence. So now they did not give us a graph. So we got to figure out what did I do to get to the next term. And hopefully you guys notice that you're basically dividing by 3. Okay, so we're dividing by 3. Alright, and we're doing that each time. Dividing by 3, dividing by 3. Remember, dividing by 3 is the same as multiplying by 1/3. Okay, so what I prefer for future reference is use the multiplication version of this. Alright, so we divide by 3. The first thing it asks us to do is we want to do the next 3 terms. So guess what? I'm going to take 9 and divide by 3. Or multiply by 1/3. So if you do that, we should get 3. Right? Because we're dividing by 3. Let's do it again. 3 divided by 3. You get 1. Again, if you're like, how to get that? Throw this stuff in your calculator. 1 divided by 3 is going to give you 1/3, okay? Or 0.3. I prefer the fraction form in this case. It's pretty easy. So we already found our next 3 terms here. So the next 3 terms were 3, 1, 1/3. Okay? So now we look here. What is the recursive formula for this sequence? So this is basically asking us, do you know the equation for this sequence? And I kind of gave you the template. So we're going to do function notation here. So the template is we're going to use b again. Again, this letter can change. If the function is an f function, we use f. If it's g, we use g. If it's d, we use d. Okay, so right now we're just going to use b. So we start with b, parentheses n, equals, and then we do b again, but this time it's going to be n minus 1 in parentheses. And then all we have to do is figure out, how did I get to the next term? What did I do? Well, in this case, we are dividing by 3, but we want to do the multiplication version of that, which I told you is multiplying by 1/3. So let's put this in a different color so you can see it. We are basically, our common multiplier in this case is times 1/3. But we're not done because this is recursive, and recursive says we got to tell everybody what's our starting point here. Okay? So our starting point, let me erase this for some room. Okay, so my starting point is this. So I like to just put this here to show, hey, this is a different part of the problem. We're using b again, and starting points are always starting points of 1. So my starting point in my function or my sequence is, and then we just look at the first number in our sequence, which is 243. So that is the recursive formula. It involves the equation, and you must put your starting point. Okay? If you skip the starting point, as you see in the notes, if you watch the video, it's impossible to do this formula. Okay? So you guys always got to put the starting point. So that's function form. And then let's do subscript form, which is very similar. Instead of using parentheses, we just use the letter at the bottom of the capital B equals b n minus 1. And then we have a common multiplier of 3, or I'm sorry, 1/3. And then our starting point is b subscript 1 equal to 2, 4, 3. Okay, So these are the function form or the subscript form. To be honest with you, just start getting used to doing the subscript form, but you'll see both on the test. Okay. All right. Part C: is this sequence geometric or arithmetic? I already know is geometric because we are dividing to get to the next term or multiplying something to get to the next term. And that makes it geometric. So it's geometric, and the reason is we have a common multiplier. Okay, and that's basically all the explaining you need. If it was arithmetic, you would have a common difference, something adding or subtracting to get to the next term. All right. Okay, describe what the graph will look like using complete sentences. So remember, when we have geometric, we're going to have an exponential graph. This is the curved one. So you use the word exponential graph. And because our numbers are getting smaller, an exponential graph that's going down. Because the numbers are getting smaller. So in other words, it's going to look like this. It starts off high and slowly goes down. Okay? Again, this is stuff I don't expect you to know it right off the bat. But just make sure you watch these notes and take your time with this stuff, okay? And then use me for the office hours if you need extra help on all this stuff, okay? We're going to stop there for the day.